My year sevens are doing statistics. And what we were doing as part of our learning was we're finding out the average number of push-ups that students could do in class 7B. Now I'm doing it with my 7A class as well, but we've got here the number of push-ups from 10 of those students from 7B. How many push-ups can they do in a row, right? And I timed them. I gave them 20 seconds each, and this is how many push-ups they could do in 20 seconds. So as you can see, student 1 was able to complete 15 push-ups, student 2 was able to complete 12, and so on. And so this video is here to try and demonstrate how to calculate the standard deviation of a set of numbers, right? And before we go into that, before we go into the actual calculation itself, I want to demonstrate what it looks like. What does standard deviation kind of look like, and what does it mean? Well, the standard deviation, and we use this lowercase sigma here, what it is it's on average, how much does each score differ from the mean or the average? And so here I've got, I calculated the mean number of push-ups. So 15 plus 12 plus 10 plus 14 plus 12 plus 9. You add them all up and you divide by 6 because there are 6 scores, and you get 12, right? So we put this 12, the mean number of push-ups for these 10 students, across, so we could easily compare the mean to each of the scores. And so standard deviation is, what is the distance, I'm going to zoom in here, what is the distance of each score, and I will use red, what is the distance of each score to the actual mean itself? Now in the second example here, there's just about no difference. This score is literally on the mean, so there's no distance at all. But what about for this student here, student 3? There's a distance there. Student 4, there's also a distance. Now, student 4's number of push-ups was higher than the mean. Student 5's was on the mean. And student 6 was below the mean. So what we can do is we can add up all those scores, and this score is from 15 to 12. The difference there is obviously 3, so we can write that there. That's 0. Student 3 was a difference of 2 there. Student 4 was a difference of 2 as well. Student 5 was a difference of 0, and student 6 was a difference of 3. Right, and that's how much they differ from the mean in terms of number of push-ups. And what we can do is we can average that out. What's the average distance? And that is essentially our standard deviation. When we're just given the numbers, like 15 and 12 and 10, we can use the formula that's up the top here. And I want to try and make the connection between what I just described with the graph and the actual symbols in the formula. So let me go ahead and describe the mean. This is the mean here. I've just circled it up the top. And that there is related to this line here in the graph, okay? So x bar is what we call this symbol, x with a bar at the top. That's the mean. It's the mean number of push-ups in this example, and it's demonstrated with the line that goes across, right? And so I'll circle another, I'll use my blue pen, and this part here, the sum of all the scores, that's related to each of the scores, or not the differences, I beg your pardon, each of the actual scores, as in the number of push-ups that each person did. So 12 push-ups here, and 9 push-ups here, right? That's what those scores are. And as you can see, if I zoom into the formula a little bit more, what's going on here is we actually have to find the total of the scores and then subtract that from the average. So symbolically, it's showing that what we're trying to find is the difference, so subtraction, the difference between each of the scores and the average. So that's what the formula is doing. It's the difference between each of the scores from the average. And then what we do is we divide that by how many scores there are to get an average. So I'll state that again. how much does each score differ, so subtraction, from the mean? What is the difference? And we divide that by how many scores there are to get an average of those scores. So that's the connection between the formula and the visual. But how can we do this symbolically? Well, what I'll do is I'll turn my page over, and I've got the numbers up here at the top. They're the same numbers. They represent the number of push-ups that 6 of these students in my 7B class were able to do in 20 seconds. So let's calculate the standard deviation. And I suppose step one would be to calculate the mean. Let's go ahead and do that. So I'll use the appropriate symbols here. Whoops. X bar is equal to the sum of my scores divided by the sum of the frequency of each of those scores. In other words, we could also write n, which is just the number of scores that there are. So as you can see, we're trying to find the sum of the frequencies. Now, each of these numbers, except for 12, occurred once. Now you can see that 12 occurred twice there. So in this particular scenario, we'll just count up how many numbers there are. Or if you want to do it this way with the sum of f, you would write 15 times 15 occurred once, and 12 occurred twice, and 10 occurred once, and 14 occurred once, and 9 occurred once, and you'd add up how many times each number occurred, and that's just the same as adding 1, 2, 3, 4, 5, 6. So it's just 6. So let's go ahead and write that down. So x bar is equal to, now let's go ahead and write the denominator. We know that there are 6 numbers. That's pretty simple. But we've now got to go ahead and add 15 plus 12 plus 10 plus 14 plus 12 plus 9, right? We've just got to add up all the scores and then divide by how many there are. Now, the total there is, and we'll write it, the mean is equal to 72 divided by 6, and that equals 12. And we demonstrated this on their graph. I already worked it out. The average number of push-ups is 12. Let's go ahead and go back to our other page, and you can see that our average number of push-ups is 12. Okay? All right. Let's go now and calculate in step 2, which is the sum of the scores, but we're going to square them now. So let's go back to our formula. I think what I might do is I might copy this formula down so we can, keep reference to it the whole time. So I wonder if I could do that. Yes, I can. So I'll go like this. And let's keep the formula up at the top right corner of the screen, and we'll refer to it as we're working along. So as you can see, I'll use green to indicate that we've now completed the mean. The mean has now been calculated. We know the mean, it's 12. We're now going to step onto this part right here. We're gonna find the sum of each of the scores squared. So it looks like this. Let me go ahead and do that part. So the sum of each of the scores squared, now we can multiply that by their frequencies, right? But because we've only got 6 numbers, we don't really need to multiply each number by how many times they occurred, because except for the number 12, they all occurred once. So we don't really need to multiply each number by their frequency. We can just do one number at a time. So that's going to be equal to 15 squared plus 12 squared plus 10 squared plus 14 squared plus 12 squared plus 9 squared. All right, so we'll go ahead and find that. And if you plug that into your calculator, you get 890. You can go ahead and put that in. So that's the sum of the square of our scores. We now have completed, and I'll use my green pen here, we've now completed the numerator of this particular formula, the standard deviation formula. We just now need to go ahead and find the sum of our frequencies, which, if you think about it, we've already worked it out. The sum of the frequencies, in other words, n, is just the number of scores. So 1, 2, 3, 4, 5, and 6. So we've got the denominator, we've got the numerator, and we've got our extra term on the end here, the mean. We just need to square the mean, which we can do quite easily, and we can start preparing for our formula here. So we'll go ahead and write this down. All right, so I might go ahead and just select all of this and resize it. So we've got a little bit more room, but it'll still be available for you to have a look at. All right, let's go ahead now with our formula. So standard deviation is equal to the square root of the sum of our scores squared divided by the sum of our frequencies, in other words, n. Let me go ahead and use a lowercase f, and then we're going to subtract that from our mean squared. So I've just rewritten the formula from here to here, and we're now going to substitute everything we know into that formula. So standard deviation is equal to the square root of, so our sum of our scores squared is right here. It's 890. So 890 divided by our sum of f, which we already know is the number of scores, which there are 6 of them. So the square of 890 divided by 6 minus the mean squared. So let's have a look at the mean. We worked out the mean, the average number of push-ups is 12. And 12 squared, well, that's just 12 times 12. That's 144. We can do that quite easily. All right. Let's go ahead now and solve 890 divided by 6. If you chuck that in the calculator, you get, and we'll write for our new line here, the square root of, and 890 divided by 6 is 148.33. And we're now going to subtract that from 800, we're going to subtract 144 from that number. Standard deviation, again, let's go ahead and solve underneath the square root sign. So 148.33 minus 144, that's equal to 4.33. And if we just go ahead and square root 4.33, we'll get our standard deviation, and that's equal to 2.08.